Okay, hello finite math students. We're going to work on just three problems in this video. The first two are pretty easy, and the third one is actually very long. Okay, so hopefully the video won't be that long, but just three problems. We're going to work on problems 1 and 2 in the simplex algorithm homework, and we're going to work on problem 56, which is a pretty involved problem. Okay, so I'm looking at problem number 1 right now in your current homework assignment, and it reads, in how many ways can two variables be chosen from x1, x2, s1, s2, s3, s4, and s5, and assigned the value 0? Okay, so this problem looks complicated, but it's really not that big a deal. Hold on one second. Let me just get my drawing tool ready. Okay, so for example, what they're talking about is something like this. Okay, so x1 could be 0, and s4 could be 0, and s4 could be 0, or s1 could be 0, and x2 could be 0. So that's really what the problem is asking, like how many different combinations are there? This is really a combinations problem. Let me write that down. This is I'm writing with my touchpad. This is a little awkward. This is a combinations. This is a combinations problem. Okay? So how are we supposed to figure that out? Well, it should be pretty easy. Okay, so I've got Mathematica right here. So I'm looking at the number of variables. I have 1, 2, 3, 4, 5, 6, 7. Okay, so I have 7 variables. How many ways can I combine them 2 at a time? So to answer that question, I would use Mathematica's binomial command, 7, comma 2. This is like a combination, okay? Shift enter, and the answer is 21 ways. Okay, and that's correct. So this is really a combinations problem, and you probably learned about that during your finite math course, which I hope. Sorry, this is the finite math course. I'm also teaching a business calculus course, and a calculus 3 course, so I'm getting all my courses confused. But if you ever studied any probability in a pre-calculus or algebra class, this is really the same type of problem. You're simply asking, how many ways can I take 7 different objects and arrange them 2 at a time if the order doesn't matter? So here the order doesn't matter. I don't care if x1 is first or s4 is first. It's not going to make a difference. Here I don't care if s1 is first or x2 is first. The order doesn't matter. Okay? So maybe you hear my dog going crazy in the background. Okay, he needs to really shut up. That's so irritating. Okay, hold on one second. Okay. So anyway, we're just gonna ignore the dog barking because we just need to continue with the video. Okay, so that's basically how you do this problem. The next problem is really the same. The next problem is the same. And let me just eliminate what I wrote. Okay. In how many ways can two variables be chosen from x1, x2, x3, s1, and s2 and assigned the value 0? Chachki, stop! Ugh. In how many ways can two variables be chosen from x1, x2, x3, s1, and s2 and assign the value of 0? So this is going to be the same thing. We have 1, 2, 3, 4, 5 variables, okay? And we're selecting 2 at a time and assigning them the value of 0. So that's... Chachki, enough. Stop the barking, please. Okay, 10 ways. 10 ways. So there are 10 different ways that you can choose two variables from a set of 5 variables and assign them the value of 0. Okay. I believe there's actually a way to enumerate that in Mathematica. Let me see if I remember how to do that. I'm going to look something up. I know it's not permutations. I know it's not the permutations command, but it's actually related to the permutations command. I would have to look that up. But there is... the problem doesn't ask for all the different combinations, so I don't think we have to worry about that. Yeah, it's not permutations. It's if you use permutations, this is what you're going to get. Permutations x1, x2, x3, s1, s2. Okay, this is what you're going to get, all the different permutations, but this is not, this is a different type of problem. Here, I believe the answer is going to be, yeah, pretty big, actually. This is really pretty big. Let me see, put in 2. Yeah, so this is not what the problem is asking for. The problem isn't asking you to enumerate all the possibilities. The problem is just asking you how many different possibilities there are, okay? I forgot, it's not the permutations command, but it's related to the permutations command. Okay, my dog finally decided to shut up. Good news for the rest of us, right? Yeah, I love him, but, you know, he's got a really big mouth sometimes. Okay, so let's continue, and let's check if this answer is correct. And the answer is correct. So they're not asking you to actually enumerate all the different combinations. They're just asking you how many different combinations are there. And there are many different combinations, right? You have x1, x2, x2, x3, x3, s1, s1, s2, and, you know, you have let me see, x1, x3, and x1, s1, and x1, s2, you know, et cetera, et cetera. You have 10 different combinations. That's what they're actually talking about. Okay, so the next problem that we're going to work on, and this is a pretty big problem, is problem 56, and I think it's a really interesting problem and demonstrates ideas in many of the other problems, okay? So let's look at this problem. The natural diet of a certain animal consists of 3 foods: food A, food B, and food C. The number of units of calcium, iron, and protein in 1 gram of each food and the average daily intake are given in the table. This table right here. A scientist wants to investigate the effect of increasing the protein in the animal's diet while not allowing the units of calcium and iron to exceed its average daily intakes. How many grams of each food should be used to maximize the amount of protein in the diet? What is the maximum amount of protein? Okay, so this can get a little complicated. This is your typical linear programming maximization problem. This is not a minimization problem, this is a maximization problem. So in this section, in this unit or chapter, whatever you want to call it, you have maximization problems and you have minimization problems. This is a maximization problems because, well, number one, here's the word maximize, and that's a big hint. Number two, I want to maximize what? I want to maximize the protein in the animal's diet. So what's confusing, well, it's not really confusing, but you have to really put on your thinking cap here. All the numbers you need are right here, but the number that you're really not interested in is the number 64. The average daily intake of protein is 64 units, but we don't really care about that. And why is that? Because it says here, a scientist wants to investigate the effect of increasing the protein in the animal's diet while not allowing the units of calcium and iron to exceed its average daily intakes. So it's okay if the scientist gives the animal more than 64 units of protein every day. Okay, it's okay, and in fact, the scientist probably will make that decision. The scientist will probably make the decision to give the animal, 64 or maybe more than 64 units of protein per day. So this number, we're not going to worry about it. We have to worry about all the other numbers, but we're not going to worry about that number. Okay? So here, what function, this is called the objective function. What are we actually maximizing? Okay? So we are maximizing the amount of protein that the animal actually eats. So the coefficients are right over here in the bottom row. These are the coefficients. So 2x1 plus 4x2 plus 5x3. And what are the constraints? Well, the calcium constraint is going to be x1 plus 3x2 plus 2x3 less than or equal to 34. Okay, so I'm not allowed to exceed 34 units of calcium per day. That's the maximum amount of calcium in the animal's diet. If I go beyond 64 units of protein per day, that's acceptable, but I cannot exceed 34 units of 34 units of calcium, and I cannot exceed 24 units of iron. Okay. And for the iron constraint, that's going to be 2x1 plus x2 plus 2x3 less than or equal to 24. And then, of course, x1, x2, x3, those three variables must be greater than or equal to 0. But we don't have to worry about that because the algorithm that we're using takes care of that for us. Okay, and this should be correct. Okay, so here's the big part. Now we have to figure out the solution to this problem. All right, I'm going to move this window right over here. I don't need my drawing tool for this. Okay, so here what I'm going to do, well, first of all, the 2x1, the 4x2, the 5x3, I'm actually going to move that to the left of p. If I move these variables to the left of p, then they're going to change sign. Instead of positive 2x1, I'll have negative 2x1. Instead of positive 4x2, I'm going to have negative 4x2. Instead of positive 5x3, I'm going to have negative 5x3. Okay, and then plus p is equal to 0. And the whole thing has to get put into the form of a matrix. So here's what I'm going to do. All right, I'm going to call it, or you can call it whatever you want to call it, matrix. You can call it matrix. Is equal to 1, 3, 2, and I'm looking at these numbers right over here. 1, 3, 2, and then 2, 1, 2, and then on the bottom I'm going to have negative 2, negative 4, negative 5. These are these numbers here, but I have to reverse their signs, okay? And let's make it look pretty. I do need that semicolon. I need the semicolon. Matrix form, shift enter. Okay, terrific. So that's the beginning of my matrix. Then I'm going to append to this the identity matrix. And the reason is because for each row, for each of the first two rows, I need what's called a slack variable. And then in the bottom row, I have my variable p, which some people say isn't necessary for the problem, but I like to put it in there anyway because I think it looks nice. Okay, and it reminds us of the variable that we're trying to maximize. So to do that, here's what I'm going to do. Join, matrix is equal to join matrix identity matrix 3, and why 3? Because my matrix here has 3 rows. 1, 2, 3. 3 rows. And level 2. And the reason I'm using level 2 is because a matrix in Mathematica is a list of lists. So you need that number 2. Matrix form. Okay, so this is slack variable 1, this is slack variable 2, and this is going to be p. That's p. P is protein. P represents protein. For this problem, it represents protein. It doesn't represent profits. It represents protein. And then finally, in the last row, I have these numbers right over here. So matrix is equal to join matrix 34, 24, and then finally remember 0. And why is it 0? Because negative 2x1 minus 4x2 minus 5x3 plus p is equal to 0. Okay. Oh. Okay, there you have it. Okay. So remember the reason, okay, so maybe I need to, well, I'm not going to write this out, guys, just for the sake of saving time, but remember that the bottom row is based on this function right over here. If p is equal to 2x1 plus 4x2 plus 5x3, that means that negative 2x1 minus 4x2 minus 5x3 plus p, and here's my p right over here, is equal to 0. So now I have to begin the simplex algorithm. begin the simplex algorithm. All right. So how do I do that? I look over here and I ask myself, what's the most negative number? The most negative number is -5, and it appears in this column over here. Okay? So then I have to look at these values over here. I have to look at these, oh, I'm having issues with this. I have to look at these values over here, the 34 and the 24. And I look at these values right over here, the 2 and the 2. 34 divided by 2 is equal to 17, and 24 divided by 2 is 12. Which one is smaller? Which is smaller? 12 is smaller than 17. So that means I have to pivot right over here. So this is going to become a 1, this is going to become a 0, and that becomes a 0. This becomes a 1 first, and then I pivot to make this a 1, and I pivot in order to transform these numbers into 0. Okay, so let's do that. Okay, I want to change the second row, and how do I change it? I multiply by 1/2. Okay. Oh, wait a second. So now I see that's a 1, but these numbers have to become 0. All right, and then my column is set to be in canonical form. Canonical, C-A-N-O-N-I-C-A-L, canonical form. All right, how do I change the first row? It's the first row. This is just Gauss-Jordan elimination, by the way. Minus 2 times the second row. And why am I doing that? Because 2 minus 2 times 1 is 0. Matrix form. And now I see I have a 0 here. Okay. And then I do the same with the third row. Matrix 3 is equal to matrix 3 plus 5 times, let me see, yeah. Matrix 3 is equal to matrix 3 plus 5 times, okay, the second row of the matrix, because -5 plus 5 times 1 is equal to 0. And then matrix form. Okay, so now I have a canonical column. It's called canonical. The word is canonical. Canonical. Okay, so it just means that you have a 1 in one position and all the other numbers in the column are zeros. But we're not finished. We're not finished. How do I know we're not finished? Because I'm looking at these numbers over here and I see that one of them is negative. So I know that the algorithm is not finished. We need to worry about this, okay? So then I'm going to go over here. 12 divided by 1/2, 10 divided by 2. 12 divided by 1/2 is 24. Okay, and 10 divided by 2 is 5. 5 is smaller than 24, which means I'm going to have to pivot right here. I'm going to have to pivot right there. Okay, so I have to go through the process all over again. Okay, so matrix, I'm changing the first row because the 2 that I want to transform happens to be in the first row. Okay, how do I change it into a 1? I multiply by the reciprocal, right? Matrix 1, matrix form, okay. And the second row, that's going to change minus 1/2 times the first row becomes a 0. And then finally, I change the third row. Matrix 3 is equal to matrix 3 plus, okay, what's the opposite of negative 3 halves? Plus 3 halves times, and then I refer back to the row that contains the 1 that I previously created, and that's row 1, and then matrix form. Okay, so we're finished. This is the final matrix. And I know I'm finished because all the numbers here are 0 or positive. Okay? All the numbers here are 0 or positive. So I know that I have arrived at a final answer. Okay? So the diet that maximizes protein intake uses... Okay, let's look at the first column. The first column is not canonical. So we assume that the value is 0. 0 grams of food A. Look at the second column. Where is the 1? The 1, okay, look at the second column, which corresponds to food B. The 1 is in the first row. So if we go to the end of that row, we see the number 5. Okay, so that's going to be 5 grams of food B. And now look at the C column, the food C column, the column that represents food C. Where is the number 1? It's here in the second row, and if we go to the end of the second row, we see the number 19 halves, which I think is 9 point... Oh, hold on. Matrix form. Okay, we'll go outside soon. I have to talk to my dog. Okay, so here in the food C column, okay, the 1 is in the second row, and if I go to the end of that row, I see the number 19 halves. Well, 20 halves, 20 halves is 10. 19 halves should be 9.5. Okay, so then the answer is 9.5 grams of food C to maximize the intake at, and the maximum amount of protein. The maximum amount of protein is that number right there. It's going to be 135 divided by 2. That's 67.5. 67.5 units of protein. And that's correct. So that was a pretty involved problem. We had to do a lot of stuff in this problem. So this problem, well, of course, it's a word problem. Okay. It's a word problem, so it's going to be kind of challenging, right? It uses Gauss-Jordan elimination, which I told you guys you're going to need for this homework assignment. It uses the Simplex algorithm, and it uses a lot. I mean, this particular, and there are many of these problems in this homework assignment. So these problems are involved because they require a lot. I mean, you really have to do a lot of work. You have to know the Gaussian elimination algorithm. Some people call it Gauss-Jordan elimination. Some people call it Gaussian elimination. You have to know the Simplex algorithm. I mean, these problems are pretty complicated. So it is to your benefit to please read the ebook. Read the textbook. You know, I think the problem that a lot of students have is they just don't read the book because they think it's tedious, they think it's boring, they think it's too long, okay? There's no other way to learn this stuff. You're just going to have to read the book, and you're going to have to go through the examples in the book. I think with most of these problems, you can open up the textbook, send me an email if you're really stuck. You can view an example. Be careful with Help Me Solve This. You can click on the Help Me Solve This option, but if you do that, your problem is going to get marked wrong, and you're going to have to do it over again with different numbers. Okay? But you guys have options. You guys really do have options, okay? Okay, so I think that's enough. Our video is now officially about a little over 30 minutes. I strongly recommend you watch this video. If you have to watch it 10 times, then watch it 10 times. Sorry about the dog barking, but there's just nothing I can do about that. So right now teachers are forced to work from home, and this is just part of working from home, So we're just gonna have to make the best of it, okay? All right, guys, I think that's enough for now, and email me if you're having issues. And